What's up? Here's another review for the final standard. I'm going to go over 7 problems in this video. If you understand all the concepts, you'll be good on the standard. There are currently 24,000 people in a rather large town. The town's population is increasing by about 150 people per year. For how many years will the town have 30,000 people? So my 2 units are people in years. If you have 2 units, you should be doing this on the standard. So the time unit is X, and then the people's Y, and then per. I write that as people per year. Okay, now the people per year, they give it to us. It's 150. It's 150 actual people. So that would be a linear equation. So I draw a straight line and just go B plus mx equals y, because you can write a y equals mx plus b equation when you have the rate of change. And it's actual, and the p and the label actually is the y unit instead of like a percent where it wouldn't be. Okay, so my m is 150x. And before 150 people per year, we had 24,000 people. So the B is 24,000. You don't need that there if you know it. Okay, and you have a nice simple equation you can write. The fact that 24,000 plus 150x equals y. Okay, so I want to know when the town's going to have 30,000 people. So 30,000, that value has to go into the equation. That would go in for the y variable. So replace the y. 24,000 plus 150x equals 30,000. Now get the x by itself. So it's being multiplied by 150, but first you got to minus the 24,000. Okay, 30,000 minus 24,000 is 6,000. So we have 150 times x equals 6,000, and then we divide both sides of the equation by 150. So 6,000 divided by 150 is 40. So it's going to take 40 years for the population to get to 30,000 at that rate, assuming the rate progresses the same way. Okay, number 2, running a website has a startup fee and a monthly cost. So monthly means per month. Running a website for 4 months costs a total of $195. Running a website for 7 months costs a total of $285. Calculate the total cost of running the website for 12 months. So again, I have 2 units working together in the problem. So we have dollars and months. So I assign X to my months and Y to my money. So dollars per month. Now I know there's a dollars per month because it says there's a monthly cost. Okay, but I don't know what it is, so I use, because I got to find the money amount. So it's Y minus Y, X minus X. It exists. Okay. So the Y is dollars and the X is months. Okay, so the dollars go from 195 to 285, and you can put those in any order, okay? If you want to go 285 minus 195, that's fine. You can also go the other way, okay? But 4 months has to be below the 195, remember that. And 7 months is below the 285, because that's what it goes with. If you want to arrange them differently, that's fine. You'll just end up with a negative divided by a negative, which is the same thing. So I subtract there, and that's 90, and that's 3. So 90 divided by 3 is 30, and I've found the dollars per month. Now I can proceed with my y equals mx plus b line graph. Okay, so my m is $30 per month. And again, I don't know what my B is because I didn't even have the $30 per month. There was a startup fee, I just don't know it. Okay, so I use y equals m times x plus b to find it. I'm going to circle my b. And these 3 variables need to be replaced. So 30 will be replacing the m. and then I go combo. Okay, combo has to appear in the same sentence. You need one of each unit. So you have 4 months, and you got $195. So months is X, so I apply 4 to X and Y to 195. So Y is 195, and then I multiply the 30 times 4. So 195 equals 30 times 4 is 120 plus B. Now remember, don't divide, okay, on this problem, because a B has a multiplier of 1, okay, so you will need to minus 120. Now I'm not actually going to divide by 1, but I'm just making a point why you don't divide. 75 is equal to 1B, which is essentially B. So my B is 75. And my equation is 75 plus 30x equals y. Okay, so 12 months is the input, and months is x. Okay, so I replace x in this problem. And my y variable has no operations with it, so I just plug that in on the calculator. 75 plus 30 times 12 is 435. Number 3. For Halloween, a person is buying Butterfinger and Reese's packages. Butterfinger packages cost 35 cents more than Reese's packages. A person buys 14 packages. That's supposed to say Reese's. Sorry, I forgot to type it. Reese's. And 17 Butterfinger packages for a total cost of $97.40. Find the cost of each type of package. Okay, put dollars down there. I forgot to do that. Okay, so I have 3 units. I got Butterfinger, I got Reese's, and we got Together. And down the line we have how many, and then per and total. Remember to put dollar signs above per and total. That means that don't put money amounts up here. Okay, now my total cost is $97.40. So something's equal to that. Okay, I know that. Okay, now find non-money amounts. Well, I got 14. That's Reese's. I got 17 Butterfingers. Now you can add those together and put 31. I really am not going to end up using the 31 for anything, but at least it's there. Okay, now Together on the price per. Now the only thing I see is the fact that Butterfinger packages cost 30 cents more than Reese's do. Okay, so with that more than, I don't need the Together. Okay, I don't need that. So I don't need Y either. I can go X plus 35 cents for one because I don't know it, but I know it's 35 cents more than the other thing, which can just be X. So X plus 35 cents is Butterfinger because it says that's more, and then X is Reese's. So I know that's 14X. Now remember to parenthesize that and distribute. 17X plus, and then I take 17 times 0.35, 5.95. Now, your X's are both on the same side of the equal, so we're going to add those right now. We're not going to minus, okay? We're just going to add 17 to 14, which would be 31X plus $5.95 equals $97.40. And then it's pretty easy to solve from there. Subtract $5.95. So I take 97.40 minus 5.95, and that's going to be 91.45. And then divide by 31. I got $2.95. Now, to know what answer that is, you go find where the X is by itself. That'd be Reese's. And the cost of the other one is just $2.95 plus 0.35. Okay, and that's going to be $3.30. Okay, number 4. Darlene's making a quilt that has an alternating stripes of regular quilting fabric and satin fabric. She spent $76 on 16 yards of the 2 fabrics at the store. Satin fabric costs $6 per yard, and quilting fabric costs $4 per yard. How many yards of each fabric did she purchase? So that's 3 units. Again. So we got together, and then we have quilting and satin. Okay. All right, then we have how many yards in this instance. Okay. Price per and price total. Okay, now my total cost is $76. Okay. Okay, find me the number that's not money. It's 16 yards, but it's of the 2 fabrics together. Okay, so you got to put 16 in the together box and have X and Y represent the 2 things you don't know. Okay, and 16's done. Now satin fabric $6 per yard, and quilting's $4 per yard. So that makes 4X, and that makes 6Y. And now you're going to need to write a system because you have 2 different variables you have to solve for. So you got that equation and that equation. You know that X plus Y equals 16. We also know that 4 times X plus 6 times Y would equal 76. Then I use my elimination. Times 4 times 4 times 4 times 1 times 1 times 1. That's 4X plus 4Y. 4 times 16, 64. And at the bottom I have 4X plus 6Y equals 76. Negative out, negative, negative. So we add those together, and 4 plus negative 6 is negative 2Y. That's negative 12. Okay. Then I divide by the negative 2, and Y equals 6. Okay. So my Y is under the satin fabric, so that's 6. Now, since I know that we have X plus 6 equals 16, we can just minus our 6, and that's 10. Okay. Okay, number 5. An antique car is currently worth $75,000. It increases in value by 10% each year. How many years will it be before it's worth $100,000 at that percentage rate? So this is going to work different. You're back to 2 units, dollars and years. So per dollars per year. Now, I don't really know the price per year, okay? The dollars per year, because it doesn't exist. You'd be chasing, if you're trying to figure that out, you're chasing ghosts. The per year rate's 10%. It's plus 10%, okay? So that's going to represent an exponent function, okay? It's not going to be a line. So with exponents, I have a beginning amount times of the rate of change factor to the power of x equals y. Or no, equals blank. Okay, don't put y there. Remember, this is my percent, and these 2 blanks are my y. They're both money, and we have the original price and the new price. Okay, let's get our percent first. Don't overthink that. You take 100% plus 10%. You don't have to worry about that divided by 4 crap. I'm not going to put quarterly on this. That's 110%. Quarterly, you just make the percent a decimal, divide it by 4, add it to 1. But I'm not going to do that. Now, that needs to be a decimal form. It'd be 1.10. Okay, now your original amount's $75,000. And I don't know the X because that's the years. That's what I'm trying to figure out down here. but I know we wind up at $100,000. So you have to solve for the independent variable this time. So if x is an exponent, you're going to need to use the log over log formula. So I know that x, whatever that expression is, in this case it's just an x, is equal to the log divided by log. So 1.10 goes on the bottom, okay? Now you don't put this on top because you have 75,000 times. What's the opposite of times? It's not minus. Quit it, okay? So you divide by 75,000. Divide by 75,000. I know a lot of people think that when it's outside the bubble, you always minus. No, because when it's on other problems, when it's outside the bubble, there's a plus sign. So yeah, you minus it, but here there's a times sign, so you divide it. Okay. So I take 100,000. Divide by 75,000, and I get 1.33. Round it. If it goes on like that, just round it. Okay. So I take log 1.33 divided by log 1.10. That takes me right to my answer. Okay. X is equal to approximately 3. Okay. Which kind of makes sense because if I start at 75,000, times it by 1.10 the first year, that's where I'm at. Times it by 1.10 the second year, that's where I'm at. Times it by 1.10 the third year, I'm a little bit over that, or I'm a little bit under that. It's not exact, okay, but it's pretty darn close. That's why it was 2.99. Okay, number 6. This is going to be the hard one, probably. An internet service provider sells high-speed internet for $30 per month to 1,500 customers. For each $1 increase in price, the number of customers will decrease by 25. Okay. Now, I think this is important. Increases plus, decreases minus. Remember that. Some of you need to take that into account. They're not both plus. Never are. How many changes in price should occur before the company stops changing the price and maximizing revenue? And what will that maximum revenue be? Now, maximums are different. I don't concern myself with units because it's a parabola. I call it Big Bertha. It's right in the middle. And the formula to find the x in the equation at that point, it's not the quadratic formula. It's not the song. It's part of the song, but it's just with opposite of b divided by 2 times a. And then I replace x. Okay, so down here, I need to come up with a blank x squared plus blank x plus blank, okay? And there's going to be a y in front of that. Now, this isn't gravity, though, so you can't just put the numbers in. You need to come up here. This is revenue, okay? When I raise revenue for something, it's always the money that I charge for an item multiplied by the quantity of items sold. So revenue is where the y is at, and then I put those in, okay? So your money. Well, $30 is your starting amount. I know it says per month, but you don't put X because it's all within the same month, okay? The months don't repeat themselves. It's just 1 month. So 30 is my initial amount. Then a $1 increase in price, so plus 1. Now, I don't know how many dollars I'm adding, so I put X to it. That's unknown. Now, I cross those money amounts out, and now here you put the other units that are the same. 1,500 is your beginning amount of customers, and then from there we minus 25X. You don't put plus 25X. A decrease clearly indicates minus. Just focus on that. Heck, I'll even let you use the Math Papa calculator to get this down here, okay, into standard form. 30 plus 1x, and then 1,500 minus 25x. And I get negative 25. That's my A. 750 is my B. And 45,000 is my C, but I don't really need my C here, okay? And for those of you who think, oh, he's just being lazy, he doesn't want to do it here, I'll just prove I'm not. FOIL, 30 times 1,500, 30 times negative 25x, 1x times 1,500, then 1x times negative 25x. Okay, that's 45,000. Makes sense. Okay. That's negative 750x. That's 1,500x, which if you combine those, you get to 750x. And then right here, you get negative 25x squared. Boom, boom, boom. Okay. You don't. So the opposite of B would be negative 750. And then I take 2 times negative 25. That's negative 50, and then I find the quotient there, that's 15. So I've raised it up by $1 15 times, and then here I just replace the x's with 15, and that's what y equals. $50,625, and you can go down and put that for your answer. Okay. So when I find a maximum, I don't really make a units box. Okay. I just need to kind of know how to get to the equation, A and a B. Okay, last one, number 7. A grenade is thrown upward into the air with an initial velocity of 200 feet per second. It's launched from a 30-foot high platform. After how many seconds does it land on the ground? The ground means the height is 0 feet at that point. Now, I'm not finding the maximum here, so I go to what I know, feet in seconds. X is seconds, Y is feet. And the feet per second rate is 200. Okay, now this would not be a straight line. The grenade's going to come down. Okay, so it's a parabolic. It's a quadratic function. Is what that's called. It's not linear. It's quadratic. Is what it's called. Okay, now you started at 30 feet, and I land at 0 feet. Okay, so now I write my equation. This would be gravity. So we know the x squared coefficient, even though the value is not in the problem, it's the gravity on Earth coefficient in algebra. Some people argue, they're like, isn't that 9.8? That's meters per second. We're dealing with a different unit. Feet per second then is 200, and then 30. Then 0 feet takes the place of the y. Okay, now x can have 2 answers. And clearly you can't put those together, so you're going to have to factor 3 terms. Okay. Okay, negative. I'm going to need the negative. X will not be needed. And the GCF out of 16,230, use your GCF calculator. It's actually 2. Okay. So negative 2 goes out, then I divide all these by negative 2, and that's positive 8x to the second minus 100x minus 15. Okay, so I'm going to take 8 times negative 15, negative 120. If you have a T-chart with a number above 100, just cross it out and go to the quadratic formula. Okay. Opposite of B, opposite of B, plus or minus the square root B squared minus 4AC. B squared minus 4AC over 2A over 2A. So the opposite of B is 100. B itself is negative 100, even though you're taking it to the second power, so it really wouldn't matter on that one what the sign is, but I'll be correct. A is 8. C is negative 15. You got to get 15 in as a negative, or this isn't going to be good. Then A here is 8. Now we know 2 times 8 is 16. Now I got to figure out the square root. So I go second, get to my square root key, and then I always need 2 parentheses at the front. The 1 parentheses comes up on its own. The second one's just for the negative 100. Now you take it to the second power by tapping x squared, and then I subtract 4, 8, negative 15. 102.37, okay? And then I go from there. You shouldn't get a domain error, you did it wrong, okay? So 100 plus 102.37 divided by 16 gives me 12.65. That's a pretty decent answer. The other one's not going to be logical, but I want to see it down here. You can put the logical answer right there, but I want to see both of them. Negative 0.02. Now you just do a quick analysis. Gee, what's more logical? Probably 12.65.